Hello and welcome back to Floodplain Friday. Nick here. This is part 3 and I'm going to talk about soil. We're moving up Lambert Creek again, now here at the Rice Lake Weir in White Bear Township. This is a neat spot because right where I stand we can see two key ingredients in our work in floodplain and wetland management. Storage behind me and restoration projects out in front of me. Here, doing a 180, is a restored segment of Lambert Creek, which is basically a narrower segment of the floodplain. The restoration was a bank stabilization and a native planting that took place in two parts. First, right here, and second, across the street, which is Oakmead Lane. So what are the benefits of these projects? For one, they stabilize the soil and reduce erosion and sedimentation going into the channel. And every little bit helps because in these areas where a straight channel picks up velocity and the water can really tear away at the banks. Second, and slightly harder to see, is the water retention and soil function. But we can't really see this on the surface, so let's take a closer look. If we were underground and could shrink, we would actually see how much is hiding out of sight. Healthy soil isn't a passive, inert thing, it's actually an active, functional system. Soil has microbes, fungi, bacteria, and decomposing critters called nematodes and protozoa, all working together to create a sponge-like structure. It's like an underground engineering department. So like your kitchen sponge, soil has open pores that let water and even air move through the ground. The ebb and flow of air and water acts kind of like this: a battery. The minerals and nutrients in the soil go through positive and negative charges as the soil gets wet, dries out, and repeats. This is a key part of the carbon and nitrogen cycles that are basically everywhere. And so the microbes, fungi, and bacteria are like the engineers in the soil, helping to maintain its open pores and structure. This structure is why soil is also referred to as a sink. It could be a sink, a sponge, tomato, tomato. The point is, a soil with structure can trap and process nutrients, sediment, or other gunk like heavy metals or chemicals. So why don't soil pores just get clogged or filled up with gunk? I mean, I can't see any pores. Well, it's kind of like working at the office. To keep a healthy workflow, we clear space, sort files, delete files, pass things on to other departments, or just recycle stuff. But have you ever been in a stressful or dysfunctional work environment? It's no fun. But sometimes it happens. And that's kind of what unhealthy or compacted soil is like. And well, that also happens. Soil compaction is common after construction and in turfgrass settings. Compaction makes soil less functional, less able to infiltrate water, and, well, more stubborn. And stubborn soil tends to move water around on the surface, where we don't really want it, because it's not actively working and processing water like a productive system. Plus, if you've tried to dig in compacted soil, you know how stubborn it can be. And so floodplain soil and wetland soil is actually really unique because they can fluctuate between wet and dry cycles. These cycles can even be a few years long before they switch from wet to dry to wet. And of course, changes in water saturation mean changes in oxygen levels. Wetland soil and wetland plants have adapted to these longer cycles, whereas upland soils and upland plants prefer shorter cycles and more space to breathe. And this takes us to our final episode, where we'll take a closer look at one more floodplain ingredient: plants.